Okay, this is section 10.5 on graphing quadratics. This is the last section that we're going to be covering in Math 95. So if I can get this adjusted to be a little clearer. So the graph of a quadratic function, ax squared plus bx plus c, the graph of this is called a parabola. The parabola could open upward, in which case the ends are going upward, or it could open downward, in which case the ends are going downward. That middle point there is called the vertex, and it happens to be the lowest point if the parabola opens upward, and the highest point if it opens downward. Now, the graph here is symmetric about that point. It means it's a mirror image on either side. We say that there's this imaginary line called the Axis of Symmetry that runs down the middle here. That is just an imaginary line, and it just means if you imagine this, like this is on a piece of paper, if I were to fold this page with the crease being on that line, these two pieces of the graph would match up perfectly. So looking at a quadratic function in standard form, this coefficient of x squared, this a value that we're used to from the quadratic formula, tells us which way the parabola opens. If a is positive, it's going to open upward. If a is negative, it's going to open downward. The quadratic functions that we're going to be looking at are going to be given in one of two forms. It's either going to be in this form, where it's already is like in that completing the square form, or it's going to be in the standard form. In this form, we're able to read off the vertex immediately. We're able to just read off the vertex as being that number h and that number k, whatever numbers are in those locations. In this standard form, it's a little trickier to have to determine the vertex. And in that case, we're going to use a formula here for that, which is not as menacing as it looks initially here. So let's start off with this completing the square form and figure out how to read this form in order to find the vertex. Now the tricky thing about this form is that this minus right here is really gonna throw us off. So looking at this first equation here, or this first function here, we get 2 parentheses x minus 3 quantity squared plus 1. Matching it up with the formula, you can see that 3 is in the h location and 1 is in the k location. See, there's the plus right there, there's the minus right there. So my vertex is 3, 1. Now a lot of students will mistakenly put negative 3 because they see that minus right there. Well, that minus is actually part of the formula. So h, that number for h, is said to be the number that comes after the subtraction. So the number after the subtraction symbol is just 3. K is the number after the plus sign, so it's 1. This gets pretty confusing, all right? Because if I change this sign and give you a slightly different function of, say, x plus 3 quantity squared plus 1, the vertex is now negative 3, 1. All right, the plus 1 is the same. That's not a big deal. But why is this suddenly now a negative 3? Because in order to get it into this form of x minus some number squared, I have to rewrite this plus sign as minus a negative. So that this h is, okay, well, what's being subtracted? What comes after the subtraction symbol? Well, negative 3 comes after the subtraction symbol because that negative times that negative gives you that positive. So it's kind of a mess, right? Now, what we end up just kind of, doing is we say, okay, in this form, if we see that minus something or other, we're just going to change the sign. Here, we're going to keep the sign. So minus 3, okay, it's going to be positive. Plus 1, keep that. Plus 3, change the sign. Plus 1, keep it. So we're just going to change on the inside, keep on the outside. So by that rationale, we get change on the inside. That's going to be a negative 1. keep on the outside. That's a negative 2. Now if you want to match it up with the formula, so again, you got to write that plus as minus a negative, and then you got to write this subtraction as plus a negative. That's a mess, right? So it's probably better to just think of it as, okay, I'm going to have to just change the sign inside and just keep whatever's outside. This one was x minus 2 quantity squared. There was no plus 0 on here. I added that as like a little plus, ghosty 0 there, because there was nothing out there. So my h, you can see here is 2, right? If you see that minus 2, you're like, whoop, inside I'm going to change the sign, that's 2. But what's outside? Well, there's nothing out there, so I just kind of put that little dotted, 0 out there to show you that if there's nothing out there, it's a 0. Similarly, with this one, there's nothing inside the parentheses, right? So don't look at this and say, oh, well, that must be my h. No. That's your k. The h is what's inside the parentheses being squared. So again, I can bring in this kind of, extra 0 in order to say, okay, these are the exact same two functions. This one, I just emphasized the fact that there was nothing else being subtracted. So my h is 0, my k is that minus 1. All right, so if I'm going to look at this one to graph it, we're going to graph these in steps. Okay, we're not just going to go straight to the graph. We're going to go through finding the vertex. We're going to find which way it opens, y-intercept, x-intercepts. It's going to be a whole thing, okay? So looking at this, we can see immediately what the vertex is going to be and which way it's going to open. The vertex, remember, inside, we're going to go with the opposite. On the outside, we're going to leave it. So it's going to be a negative 2, negative 4 for my vertex. This A right here tells me which way it opens. It's negative, so it opens downward. That means the ends of my parabola are going to open down. They're going to point downward. To find the y-intercept, remember, to find y-intercepts, you have to plug in 0 for x and then solve. So going back to this original function, so there's my original function there. I'm going to plug in 0 for x. You can just bust out your calculator and do all that at one time, and we get negative 12. To find the x-intercepts, that one's going to be a little messier here. To find the x-intercepts, we have to plug in 0 for y and solve for x. So I'm going to put a 0 over here. Now here's the thing about this. Okay, there's always going to be a y-intercept. Okay, and there's only going to be one of them, and they're easier to find. But the x-intercept, there may be no x-intercepts. There may only be one x-intercept. There may be two x-intercepts. And they're going to be messier to find. So that's why I knock out the y-intercept first. The x-intercepts, you may have to solve some equations, as you're about to see. So substituting 0 in for y. To solve this, I'm going to add 4 to both sides and then divide by negative 2. And I get x plus 2 quantity squared equals negative 2. So then what happens? Well, we've got, something squared, so we're going to take the plus or minus square root of both sides to get rid of that squared. But look what happens when I do that. I get the square root of a negative. That means my solutions are imaginary. Now normally it'd be like, yeah, that's fine, okay, I'm just going to throw an I on there. But for graphing purposes, imaginary solutions mean that there are no x-intercepts. Now let me just show you a pro tip here. You could tell before doing all of this that there were not going to be any x-intercepts, and save yourself the trouble and all the work. If you look carefully, the vertex and which way it opens will tell you if there's going to be any x-intercepts. The vertex was negative 2, negative 4, and it opened downward. So look, it's like this. It doesn't curve back up at any point. So that's what it looks like. It may be wider or skinnier, but in any case, it's never going to touch the x-axis, so it has no x-intercepts. So you can save yourself the trouble of going through all this and solving to get these imaginary answers only to be like, oh, no solution. So you can kind of save yourself the brain damage there and just use the vertex and which way it opens to determine if there are any to begin with before you go trying to find them. So here's what we get. We have that the vertex is -2, -4. It opens downward. We've got a y-intercept at -12 down there and no x-intercepts. So here's what the graph looks like. Because it's symmetrical, just having this vertex and this one point right here is enough. Because then we know however wide it is on this side, that's how wide it's going to be on that side, because it's symmetrical. I'll come back to the range and explain that one later, so hang on to that. I'll be back for that one. Okay, so let's look at another one that's in this form. From this form, we can immediately read off the vertex, and we can know immediately which way it opens. The vertex is, remember, change the sign, leave the sign. So +1, -3. A is a +1/2, so it opens upward. The y-intercept, you're just going to plug in 0 for x, and that's just going to be a straight computation. Nothing to solve, no doing this to both sides or anything like that. You just get a straight computation, you just put in your calculator. So you end up with -5/2. I changed it to a decimal because we're graphing it, so it's easier to see, where it is in decimal form. All right, before we go and find the x-intercepts, are there any x-intercepts? Well, let's see. The vertex was at 1, -3, and it opens upward. All right, so yeah, it does have some, right? Depending on how wide or how skinny, it might be like super skinny, it might be like really fat and everything, but it does cross the x-axis. Right, so it does have some. So we're going to let y equal 0 and solve for x. So 0 equals that 1/2 x minus 1 quantity squared minus 3. I'm going to add 3 to both sides. So that'll give me 1/2 x minus 1 quantity squared equals 3. To get rid of this 1/2, I'm going to multiply both sides by 2. That way that 2 and that 2 will cancel. And I get x minus 1 quantity squared equals 6. Once again, I end up with a squared, so to undo it, I'm going to take the plus or minus square root of both sides. That square root will undo that squared, and I'll get x minus 1 equals plus or minus root 6. So getting that x minus 1 equals plus or minus root 6, to finish solving that for x, I'm going to undo that minus 1 by adding 1 to both sides. Do not try to combine those. Do not try to tell me that's the root 7. Those are not like terms. And even if they were, you couldn't add them that way. So I end up with 1 from right here, and then the plus or minus root 6. Because we're graphing this, you really should just change these to decimals. So I just used the calculator on those two answers, 1 plus root 6, 1 minus root 6. And I got those two x-intercepts. So here's everything from all those parts that I was just doing. We got the vertex, we know which way it opens, we got a y-intercept, a couple of x-intercepts. So just playing a nice little game of connect the dots. There we go. Don't worry about the range, I'll be back for that. Now, if you get all these points and you go to connect them, and it's just a bunch of hot garbage in some, janky looking graph, if your points don't connect into a nice smooth parabola, if you get like, I don't know, a vertex over here, and then there's one x-intercept, and there's another, and your y-intercept's here, and you're like, you know, you get some weird janky looking thing, you messed up. So you should be able to play a nice little game of connect the dots and get something that's nice and smooth and symmetrical. All right, let's look at this one. This one's going to be in standard form. It's not going to have that, that completing the square form. With this one, you could complete the square and get it into that form and then continue like we were doing. But there is another way that you can do these that are in standard form. And that is to use this formula. Now, here's what we're going to do. We're just going to use negative b over 2a. This is just telling you, just plug in the number you found. Plug in whatever number you find right here for this, whatever answer, just plug that answer in for x. So what is this b and a business? Well, this is the same a and b that we use from the quadratic formula. So looking at this, we know that a is 1, b is negative 8, c is 7. So negative b over 2a is negative from the formula, b is negative 8, and then 2a, a was 1. So that ends up being 8 divided by 2, which is 4. That's the first part of your vertex. Remember, your vertex is two numbers, an x and a y. There's your x. Now, this is just a mathy way of saying plug in that number you just got. All right, so we're going to go back to this function, and we're just going to plug in that number I just got. So that's why I kind of accented it in pink and said, okay, here we go. We plug that in, but break out the calculator, we get negative 9. So my vertex is 4, negative 9. Which way does it open? Well, let's look back up here. Remember, a was 1. That's positive, so it's going to open upward. The y-intercept, we're going to plug in 0 for x. So going back to the x squared minus 8x plus 7 business and plugging in 0. This is really easy, right? 0 minus 0 plus 7, 7. The x-intercepts, we're going to let y equal 0. In doing that, we get this that we're going to have to solve by either factoring or the quadratic formula. Remember, the y-intercept, that's easy to find. It's just a computation. The x-intercepts, those can get messy. I factored that because it factored pretty nicely, and I got 2 x-intercepts. 1, 0, 7, 0. Don't make that into one point. Don't try to make that the point 1, 7. No. These are two separate x values that are the locations of two separate x-intercepts, both of which have a y coordinate of 0. So x, y, and the x value of 7, the y value of 0. All right, and then just plotting all those points that I got for the vertex, the x-intercepts, the y-intercept. All right, so let's talk about the domain and the range of a parabola before we go and do some more of these. The domain of a parabola, and I shouldn't say the domain of a parabola, I should say the domain of a quadratic function that opens up or down. It's always all real numbers because they always go infinitely left to right. The range is going to vary from problem to problem, okay? The range, remember, is the y values, and that's how far down and how far up the graph goes. So this one, the lowest that it goes is -3. The highest it goes is infinity. Whereas one that's opening downward, here, this 2 is its highest point, and its lowest, well, it doesn't have a lowest point. It goes down to -infinity. So we say that for this one, the range is -3 to infinity. For this one, the range is -infinity to 2. Remember with interval notation that it's always smaller, larger. So you don't want to put 2, -infinity. You always want to say smaller, larger. And it's always going to include the y value of the vertex because the range has to do with the y values, and the vertex is going to be that lowest or highest point depending on which way the parabola opens. So let's just flip back and go see some of these that we did already. So let's look at this one. The range for this one, it goes down infinitely, and the highest it goes is -4. That's the y, that's the range. So the highest point's -4, the lowest point's -infinity. Remember, the bracket means it touches that point. The parenthesis means it doesn't touch that point. For this one, it goes up forever, so that's the highest point. The lowest point, the y value there is -3. For this one, the lowest point here was -9, and then it went up forever. So the range was -9 to positive infinity. So let's look at one that's in standard form again. Let's go back to that -b/2a business for the vertex. In figuring out what b and a are, remember that the standard form is ax squared plus bx plus c. So this is the same thing as this. That means that a is 7, that's the coefficient of x squared. B is 0, it's the coefficient of x. There's not an x term, that's why it's 0. And c is 9, the constant. So then -b/2a is -0 over 2 times 7, which is just 0. Remember, this is just telling you plug in the answer that you get for the first part. So okay, plug in 0. So we get 7 times 0 squared plus 9 equals 9. Alright, so we get a vertex of 0, 9. Which way does it open? Well, my a value is 7, which is positive, so it opens upward. The y-intercept, let's plug in 0 for x. Okay, so it's 7x squared plus 9, so we're going to plug in 0. That looks familiar. Like maybe we just did that up here. It works out that my y-intercept happens to also be my vertex. That's why I picked this one, because I knew that there was going to be some weirdness happening there. Okay, so let's talk about the X-intercept or intercepts, which incidentally Hawks calls these zeros. That's pretty common to call X-intercepts zeros or roots or things like that. There's not going to be any. How do I know that? Because my vertex is right here at 0, 9, and I know it opens upward. So see that parabola? Does it ever touch the x-axis? Nope. So there's not any x-intercepts. Now, if for a good time you just decide, you know what, I'm going to set that original thing equal to 0 and I'm going to solve it and get those imaginary answers, well, you do that. You go for it. But you don't have to. All right, so here's what we get. From all this information, the only point we have is 0, 9. That's not enough. We do need to find 2 additional random points. So, random being the key word here. Pick any number you want. I just chose 1 and -1. And plug those into the original functions there. So plugging in 1, I got 16. So that gives me the point x, y. Plugging in -1, I got 16, which gave me the point x, y. So now, looking at all 3 of those points, now you can get a feeling for what that parabola looks like. Without these 2 points, you can't just graph it with just this. You can see up here when I just kind of sketched it out, I didn't know how wide it is. I mean, it could be wide, it could be, you know, super skinny, you know, anything like that. But I knew that it opened upward. That's all I needed to know to say, okay, there's no x-intercepts. But by finding these extra points, that tells me just how wide or skinny that parabola is. Okay, that concludes section 10.5.